So we have a circuit here. We have two parts to this question. Part A says to find the equivalent resistance of all of these resistors combined. So essentially we're just working on two main rules here. When let's say any two resistors are in series, you add the resistances directly like this. When any two resistors are in parallel, you kind of do the following. You add the inverse of the individual resistances, and then you take the inverse again of both of those. So these are like the two main rules we're going to use here to solve part A, and then later we'll get to part B and how to do it. So the first thing I'm going to do is I'll redraw the circuit because it's going to become more clear, what's in series and what's in parallel, especially because this part here is really looking weird right now. So I'll draw the circuit again. That's R1. Down here we have R4. Here we will have R5. Here we have R1, and now here that branch that's leaning is going to be sort of straight up with R3. So that's R3. And this is R2. And this is R2. Now what I'll do is I'll probably change the color of the background. I'm planning on copy pasting this. What happened here? Oh, there we go. I'm planning on trying to copy paste this or make it a little smaller maybe. There we go. Now to find the equivalent resistance, we'll start on the right hand side. We know that these two resistors are in series. Why? Because they're sort of because of the fact that the same current that goes through R2 over here goes through here. Essentially, the current that's going this way has no other route to take other than going down, because there is no wire going out here or going somewhere else up there, for example. So we use that rule that I showed you a minute or two ago for resistors in series. So what we're doing is instead of saying R equivalent, I'll call it R22, which is going to be equal to R2 plus R2, which is R2 is 4 ohms. So 4 plus 4 is equal to 8 ohms. That's awesome. So all of this is 8 ohms, and that's R22. Now I'll erase that because it gets way too messy. I'll use orange. So what I've really done is taken this loop and combined those two R2 resistors into one resistor called R22. So now I know that R22 is in parallel with R3. So now I'll use the parallel rule for resistance. I'll call this R223 is equal to 1 over R22 plus 1 over R3, all of that inverse. This is 1 over 8 ohms plus 1 over, what is R3? It is 6 ohms. 6 ohms inverse. I'll calculate that. 1 over 8 plus 1 over 6 inverse That is going to give me 3.43 ohms. So now I'm going to sort of get rid of the calculation. So what did I just do? I took R22 and combined it with R3 into one single branch. So what I did is I did this. There we go, and this is now R223. Basically, to make it look clearer, that's R4, this is R1, and this is R223. I condensed that entire thing here, got rid of it. So that made, now that you know what we're looking at, that's great. So R223 is equal to 3.43 ohms. I'll erase this here. Now we'll move on to the next step. Now I know that R223 and R1 are in series. Why? Because the current that's going through here has no other option but to go down. And so the same current is flowing through each of these two resistors, R223 and R1. So that's awesome. These guys are in series, so what do? I find the equivalent resistance R1223 is going to be equal to R1 plus R223. This is equal to R1 is 4 ohms plus R223, which is 3.43 ohms. This is going to be equal to 7.43 ohms. That's for R1223. Awesome. Now I'll erase this stuff. So what did we do? To make this look a bit simpler, I took both R223 and combined it with R1 because they're in series, and basically I put them into one single branch like this. Now ignore the rest of the circuit from here to here. Pretend like it doesn't exist any longer. It's been condensed down into this blue thing here. So this is R1223, which is equal to 7.43 ohms. And this, I know this massive circuit is going to get dirty as we continue to solve more, but I'll leave it as it is. I'll choose purple or blue, whatever it is. Now I know that R4 and R1223 are in parallel to each other. So again, apply the parallel rule. I'll call this R1223, the parallel rule of resistance. So it's 1 over R1223 plus 1 over R4, all of that inverse. Okay, so basically it's 1 over R1223, which is 7.43 ohms, plus 1 over R4, which is 2 ohms, down here. Inverse. Now I'll plug this into the calculator. That gives us a resistance of 1.57, well, 1.58 ohms. I'm basically kind of like rounding my answers, but it shouldn't matter. Weber should be able to accept this many decimal digits. Okay, so I combined these in parallel. So what did I do? I basically took R4 and I took R1223, combined them into one single branch because they're in parallel. So now all of this looks like this. And this guy here is, I'll have to probably make my writing smaller. Maybe a font of 3 is good. So this is R12234. So again, ignore the rest of the circuit, like all the way from here to here. Pretend like it's all been condensed down to a single branch, into this blue branch. Now we have a very easy, simple circuit. All of this, just one simple circuit. That's nice. Okay, so I'll have to erase my writing down there, because again it gets way too messy. 1.58 ohms is what we have here. I'll have to put it up here. Okay, awesome. So I'll erase all of this. So I think you guys are kind of getting the idea by now that you're just, for the equivalent resistance, you just draw the circuit again, make it look simpler, and then you just condense it down using the various rules. The two rules, the rule for series resistors and the rule for parallel resistors. Now here it's kind of somewhat easy. We know that whatever current is flowing through R1 is also flowing through R1, 2, 2, 3, 4, and is also flowing through R5. So all three of these guys are in series. What does that mean? I'll change my color again. I'll make it, I think, something dark. So now I'll say R equivalent is equal to R1 plus R1, 2, 2, 3, 4 plus R5. So now I'll plug in these numbers. So 4 ohms plus R1, 2, 2, 3, 4, which is 1.58 ohms, plus R5. What is R5? It is 5 ohms. I plug this into the calculator. And that gives me 10.58 ohms as the equivalent resistance for the entire circuit. So what have I done here? I'll make my handwriting bigger. I've taken all three of these guys, R1, 2, 2, 3, 4, R5, and R1, and combine them into one single resistor. So now what I have left is just an empty wire here, and then that one single resistor here, which is my R equivalent. So I took everything, all of that stuff, and just combined it into one circuit. Sorry, not one circuit, one resistor. That's what I've done. So R equivalent is 10.58 ohms. Now I'm going to erase all of that. So yeah, as you can see, the answer here is 10.37, but when I plug it into WebWork, it'll also accept 10.58 ohms. I'll just double check that quickly. It really shouldn't matter. Again, the reason my answer kind of deferred was because I rounded. Oh, well, yeah, it works. Okay, that's great. So that's awesome. I'll stick with 10.58 then, because I want to stay consistent. It's 10.58 ohms here. Great.